Hi, in this series we're looking at the wonderful world of compute shaders. In a previous episode I created a 2-colour vertical gradient, and in this episode we're going to extend that to be a 3-colour vertical gradient. We can no longer assign the colours to the vertices, so we're going to have to use the fragment shader. Let's get started. I started this from the 2-colour gradient episode, but all I have here is a quad parented to the camera, nothing you can't set up yourselves. We need a whole new shader for this, so right click, create shader, unlit shader. We'll call this triple vertical gradient. Right click on the shader and select create material. This creates a material from our shader. Drag it onto the quad to assign it. Let's get started on the shader code. Same as last time, we're not using any of the texture or fog components, so we'll remove that as we go. I'm envisaging you using this for a background. If you actually want to apply this to objects in some other way, you can leave it in. First up, we need to get rid of that texture property and add in our colours. We'll need 3, so we'll have top colour, middle colour and bottom colour. They're all of type colour, and I've given them default colours of purple, yellow and red, so we can have a nice sunset style gradient. You can put whatever you like in here. In reality, you'll be setting these in the inspector or via code anyway. We could fix the location of the middle colour to the middle, but that's needlessly limiting. So we'll include an extra parameter, middle position, which will be the location as a percent, so a value 0 to 1. This will be how far away it is from the bottom gradient, so our default of 0.2 here will put it 20% up the quad. In our pass, we can get rid of the multi-compile fog line. We'll make no changes to either our app data or v2f structs, apart from to remove the fog coords. In the vertex shader, we don't need the texture or fog stuff, so we delete the 2 variables and the relevant code. We do, however, need to set the output UV component, as that's how we'll create our gradient. So we'll just pass that straight through, as we're going to do everything in the fragment shader. We need to define our 4 properties before the fragment shader so we can access them. So put top colour, middle colour, bottom colour and the middle position definitions here. In the fragment shader, let's get rid of texture and fog to leave ourselves with a blank canvas. So I'm going to do this in 2 ways. The first uses an if-else statement, as this helps to convey what we're trying to achieve, and then I'll optimise that out afterwards once we've got it working. So we'll start with a variable definition for our fixed for colour variable that we'll return. The UV mapping looks like this. The origin 0, 0 is in the bottom left and 1, 1 is in the top right. But just like the 2-colour gradient, we can use the uv.y to tell us where we are in our gradient. We've got 2 cases. First, if the uv.y value is less than our middle position, which I've indicated on our diagram with a yellow line, then we want to linearly interpolate between the bottom colour and the middle colour. We can't just use the uv.y value as a percentage in our lerp though, as the end percent needs to be 1. We can rectify this by dividing by the middle position. If you think about this now, 0 divided by 0.2 equals 0 at the bottom, so that's all good, and 0.2 divided by 0.2 equals 1 in the middle. Else, we'll need to lerp between the middle colour and the top colour. Again, we need to think a bit more carefully about how we calculate the percentage for the lerp. We want our middle position 0.2 to map to 0 and 1 to map to 1 at the top. So if we first rebase our uv.y value by subtracting the middle position, we now have the start at 0. This means our endpoint is 0.8 when using this 0.2 example. But that's okay. This is now just like the first section. We can scale this by dividing by 0.8, which is 1 minus the middle position. Hopefully the illustration on the left here helped convey the process I went through there. These mathematical manipulations aren't easy for everyone, so if you have to rewatch that bit, don't worry. Finally, we just return our col variable. This will work, so let's jump back into Unity to see it in action. That's looking super cool. I'll just switch to game view so we can see it better. This all works. We can change the middle position and the colours. Nice. Let's jump back into the shader and talk about optimisations. When doing any computation on GPUs, branching is one of those taboo areas which are considered bad. This is because GPUs are massively parallel and they have what is called a SIMD architecture, that's single instruction, multiple data. So all the threads working together need to execute the same thing, which is great for doing similar things fast. But in the worst case, it can mean that all threads execute both the if and the else branches and just throw away the one they don't need. If you're doing a simple 2D game and want a gradient background, firstly, you probably don't care about optimization at this level, Also, in this case, close pixels are likely to fall into the same branch, so it's probably not an issue. The only time you would see this is if the square of pixels you're rendering straddles that middle position, as the top half would be doing the if and the bottom half would be doing the else. Determining if it is an issue would involve profiling the shader, it would vary by GPU, and that's a whole other can of worms. Having said that, I'm going to run through the thought process of how you could attempt to optimize out the if statement, because that's the sort of thing I find fun, so maybe you do too. The first thing we can do is determine which branch we're taking with the step function. This returns 1 if the first argument is greater than or equal to the second. So if uv.y is less than the middle, it returns 0, else it returns 1. We'll store this in a variable called isTop. We can then use this to pick the two colours using lerp. As the value is only ever 0 or 1, it doesn't actually do any lerping, it's just acting as a selector. So we're using it for convenience. So if we're not in the top, we choose the first parameter and have bottom and middle as our colours. And if we are in the top, then we choose the second and have middle and top. The tricky bit is calculating the percent to lerp between, as the two intervals are different. Let's start with the numerator. For the first position, this is just uv.y, and for the second, we need to subtract middle position. If we multiply middle position by isTop before subtracting it, this will give us what we want. It will zero out when we're below the middle, as it's multiplied by 0, and leave it there if we're in the top, as it's multiplied by 1. The denominator is a bit harder. We want to go up to the middle position in the bottom and 1 minus the middle position in the top. So rather than 0, 1 this time, we need to get the sign of the middle position and need to map our isTop variable as 0 to 1 and 1 to minus 1. The function to do this is minus 2 times isTop plus 1. If we step that through, when isTop is 0, it's just minus 2 times 0, which is 0 plus 1 equals 1. And when isTop is 1, it's minus 2 times 1, which is minus 2, plus 1 is minus 1. Great. Putting that all together, we can now return the linear interpolation between our two colours with this percent. Back in Unity, you can see that nothing has changed, it all still works. I hope you found this tutorial useful in some way. As ever, the full code is available in GitHub and is linked in the description below. See you next time.